Okay, tutorial question 2 gives you fx equals to x squared minus 6 lambda x, and you are supposed to find ff lambda. Now what does this ff lambda mean? Ff lambda is actually just a composite function. You're doing f 2 times. Okay, so first, before you can find ff lambda, you need to find what is ffx, and it's again just doing f 2 times, so it is this, which really just means that I have something not very simple. Okay, but once I substitute lambda in, I get this. Which is a lot simpler, definitely. Okay, you should all be able to get this far. And for part 2, the range of f. The range of f, firstly you need to realize that this function here is a quadratic function. If it is a quadratic function, means it either has a maximum or a minimum. In other words, you don't expect to see the range to cover the set of real numbers. It needs to either look like this or like this. Okay, so because the coefficient of x squared is 1, you expect that x squared minus 6 lambda x has a minimum point. In other words, it should look like a smiling face. How do we find this minimum point? The simplest way is to do completion of square. So if I have this, I would actually be able to complete the square and get this. Okay, and this would directly tell me that minimum point is at 3 lambda negative 9 lambda squared. So that means negative 9 lambda squared is the lowest value that I can ever get for x squared minus 6 lambda. So my range of f then needs to be from negative 9 lambda squared to infinity. Okay, and it should be square bracket. Okay, so that's the first bit. Give a reason why f does not have an inverse. Remember, for f to have an inverse, it needs to be a 1 function. Then you think about it, it's a quadratic function, something that looks like this, something that looks like this. Is this a 1 function? If you carry out the horizontal line test, you notice that it cuts more than 1 time. So actually f does not have an inverse. Because it is not a 1 function. Now to substantiate this, you can either draw the graph Or you can state that by horizontal line test, f is not a one function and therefore it does not have an inverse. Okay. So what they then told you is that if I restrict the domain to either be before a certain value k or after the same value k, then it has an inverse. This tells you that this k is actually the midpoint, the point of symmetry there, because otherwise at any other point, notice if I had chosen any other point, let me sketch it for you. If I had chosen this to be k, for example, okay, if I restrict it to x less than k, it works, it is 1 1. But if I then look at the same k and greater than or equals to k, it is no longer 1 1. There are some points which for the same value of y, there are two values of x. So for the only possible case is actually k being smack in the center at the line of symmetry, which means that k needs to be at your minimum point. Now because you completed the square earlier, it makes things a lot easier. Now I have k has to be equals to 3 lambda. Okay, and from then on I'm supposed to find the expression for f inverse x corresponding to each of these domains. Okay, so my case 1, x needs to be less than or equals to 3 lambda, and case 2, x greater than or equals to 3 lambda, y equals to x squared minus 6 lambda x. Remember, again we need to isolate x, and this is not a fun proposition, I would say, because it's quadratic. But remember, you have the quadratic formula, so we do this. X equals to plus minus square minus c. Okay, so I have f inverse x actually equals to 3 lambda plus minus square root of 9 lambda squared plus x, and this formula should actually be the same for both. The only thing that should be different is whether it's plus or minus, and as such the domain and the range. So I'm going to leave it as plus minus, but if we think about it, I need my range to end up as the range of, let me start that again, if my original domain of fx is x less than or equals to 3 lambda, then my range of f inverse x also needs to be x less than or equals to 3 lambda. I need to go back to the same place, and here I have 3 lambda plus something or 3 lambda minus something. So obviously, because I want to go back to x less than 3 lambda, I need to choose the minus option. Okay, and for the other one, because I need it to be greater than 3 lambda, it should be plus. Okay, but that's not the end of the question. Well, what else did the question ask us for? Corresponding to each of these domains, yes. Okay, so it's not complete because we haven't quite stated the domains of this yet. This will have been for x in negative 9 lambda squared to infinity, and the other one also similarly. Okay.